we're going to continue on with the end of chapter 6, 6.7 of polygons in the coordinate plane. And so we have 3 objectives today. By the end of the class, you'll be able to use formulas and properties of special quadrilaterals to ID these in the coordinate plane. And specifically, you're going to be able to use the distance formula so you can determine the length of a segment. To do that, to determine whether the sides are congruent or the diagonals of a quadrilateral are congruent. You can use the midpoint formula to determine the coordinates of the midpoint of a side or determine whether diagonals, for example, bisect each other. And you can use the slope formula to determine whether sides or diagonals are parallel or perpendicular. All right, great. So let's get started with some notes today. So again, in previous chapters, we've talked about the distance formula, the midpoint formula, and the slope formula. In addition to being up on our word wall and in your previous notes, I put them here for you here as well, so you have them in here in these notes. And so today, what we're gonna do is again use the distance formula to determine the lengths of stuff, so that you could determine whether sides are congruent, or for example, whether diagonals are congruent. Right? If opposite sides are congruent, then it would be a parallelogram. If diagonals are congruent, it would be a rectangle, just for example. You can also use the midpoint formula to determine things, to determine the coordinates of the midpoint of a side, or you could determine whether midpoints bisect each other, because again, for all parallelograms, the midpoints bisect each other. So if you can find the midpoint, and that midpoint is where they actually meet, then by definition they bisect each other, so it must be a parallelogram. And then finally, you can use the slope formula to determine whether opposite sides are parallel, because of course, if lines are parallel, then their slopes are equal. You can determine, for example, whether diagonals are perpendicular, like for example, in a rhombus, diagonals are perpendicular. And if lines are perpendicular, then their slopes are opposite reciprocals. You could also determine, for example, whether sides are perpendicular, for example, in a rectangle or square. All right, to determine whether or not 2 lines are perpendicular, they have the opposite reciprocals. To remind you what opposite reciprocals are, if one slope is A over B, then the reciprocal is I flip that around, so that would be B over A, and then opposite means I change the sign. So if one slope is A over B, the opposite reciprocal of that is negative B over A. Or the other way I can determine whether 2 numbers are opposite reciprocals is if I multiply them together, the product of any 2 numbers that multiply together to be -1 are opposite reciprocals. So if I've got 2 slopes, in this case M1 and M2, and I multiply them together and I get -1, then I know that they're opposite reciprocals, so those slopes are of lines that are perpendicular. All right, so that's all we have for notes today. So now let's do some example problems. Again, our first objective was to be able to use the distance formula to help us classify quadrilaterals in the coordinate plane. So let's do that. All right, right here I have a triangle ABC, and it's asking me to determine whether triangle ABC is scalene, isosceles, or equilateral. So what I'm going to do is I'm going to use the distance formula. I'm going to do it 3 times for all 3 sides of the triangle, AB, BC, and then CA. And then I'll use a distance formula for them, and I'll be able to see the distance of the sides. And if all 3 sides are different, then it would be a scalene triangle. If 2 of the sides are equal, it would be an isosceles. And if all 3 sides are equal or congruent, then it would be an equilateral triangle. So let's use our distance formula to determine whether that's true. So first, we're going to use the distance formula to determine what is the distance of AB. So if I plug in my values here, as you can see, I put them in colors, so you can see the A is in red, the B is in blue. Plug those numbers in there. I get the square root of 16 plus 9, which is the square root of 25, which of course is just 5. So I know the length of AB is 5. Excuse me. All right. So now BC, I do the same thing, plug those values into my distance formula for BC, and once again, just simplify it, and then when I simplify the radical, I see that the answer is 5. So AB is 5, and BC is 5. Now let's look at AC or CA. Plug those numbers in, and I get that's the square root of 50, or 5 root 2. So now I can see that 2 of the sides, AB and BC, are both equal to 5. And so they must be equal to each other. So this ABC triangle ABC must be an isosceles triangle because two sides are the same. All right, you can pause the video and get this down for your notes, and then we'll go on to the next example problem here, which is about this example problem. The objective we're going to use is to be able to use the midpoint formula. And here's an example of that. This right here, KITE, quadrilateral KITE, is a kite. And it's asking us, what is the most precise classification of the quadrilateral formed by connecting the midpoints of the sides of this kite? So to do this, I'll have to first find the midpoints of the four various sides. Then I could draw it in on this coordinate plane and then see what I know about this new shape to be able to classify it. So the first thing I have to do is I have to find the four various midpoints using my midpoint formula. So there are the four different points for K, I, T, and E. And so to find the midpoint of each side, to find the midpoint between K and I, I'll call that point A. When I plug that into my values, I can see it, that's -2, 2. For the one between the midpoint of IT, I'll call that point B. Again, just plug that into my formula, and I get that that's going to be 4, 2. For the midpoint of TE, I'll call that point C, and when I plug that into my formula, I get the midpoint of that is 4, -2. And then finally, the final midpoint is the one between E and K, which I'll call point D, and when I plug that in, I get -2, -2. So now let's just redraw, take that first diagram, and then draw ABCD right on it. So it looks like this, and I put ABCD in blue, so it's easy to see. And so you'll see that I have quadrilateral ABCD. Now I have that. Now I need to figure out what characteristics of it, what properties of that, so that I can identify what kind of quadrilateral ABCD is. And the first thing I should notice is that if I just use the distance on a number line, I don't need to use the distance formula to determine, for example, how big AB is, because it is a horizontal line. I could just count it, just count between A and B. And when I do, I see that that's 6 units. And the same thing is true for CD. That is also 6 units. And then I can do the exact same thing for the two lines that are vertical, BC and AD. Those two, if I count them, again, I can just count them because they're horizontal, they're vertical, straight up and down. I can count those, and those are each 4 units each. So the first thing I can see is that if I have a quadrilateral whose opposite sides are congruent, because AB and DC are both 6, those are congruent, and the left and the right sides, AD and BC, are both congruent, those are 4. So anything with opposite sides congruent must be a parallelogram. So I know that ABCD is a parallelogram. And while that's true, I can be even more specific, because if I look even more, I can see that because the AB and DC lines are perfectly horizontal, that's why we could just count to determine the distance, and the AD and BC lines are perfectly vertical. That's why we could just count to count the distance. Well, any lines that meet at horizontal and vertical are going to be right angles. So for example, angle A and angle B and angle C and angle D are all right angles. So if I have a parallelogram that has 4 right angles, then by definition, that is a rectangle. So I know that quadrilateral ABCD is a rectangle. All right, you can pause the video while you all take notes, and then we can move on to the next one here. The third and final objective for today is to be able to use the slope formula to determine how to ID different quadrilaterals in the coordinate plane. So let's do an example of that. All right, so we have a parallelogram, excuse me, not a parallelogram, we have a quadrilateral ABCD, and it's asking, is that a rhombus? Explain. All right, well, one of the characteristics we know about a rhombus, one of the properties of a rhombus, are that its diagonals are perpendicular. And over in this drawing here, we have these diagonals drawn in blue. So if I find the slope of those two blue lines, and then if they are opposite reciprocals, then those lines must be perpendicular, so it must be a rhombus. If those two lines are not or the slopes of those two lines are not opposite reciprocals, then they're not perpendicular. And if they're not perpendicular, then by definition, it can't be a rhombus, because if it's a rhombus, its diagonals will be perpendicular. Great, so let's go through and do this. We're going to use the slope formula to find the slopes of the diagonals. So the first slope, AC there, between -2, 0 and 4, 5, when I plug that into my slope formula, I get that I'm 6/5. So again, rise over run, I am rising up 5 and then running to the right 6 between point A and C, and that gets me my slope, 5, 6, rise over run. All right, now let's do the same thing for BD, between B, 0, 4 and D, 2, 1. When I put that into my slope formula, I get that the slope of BD is -3/2. So the next thing I need to do is either find the product of the slopes, is what it's suggesting here, or I just need to determine whether or not these two are, whether or not they are opposite reciprocals. So if I just look at them, 5, 6, the reciprocal of 5, 6 would be 6/5, and so the opposite reciprocal will be -6/5, and I have -3/2, so they're not opposite reciprocals. Or conversely, the opposite reciprocal of -3/2 would be 2/3, not 5, 6. So you can either do it that way, or as this is suggesting, you can multiply the slopes, and when I multiply these two, I get -15/12 or -5/4 if I simplify. So that's awfully close to -1, but no, it is not equal exactly to -1. So the slopes are not -1, so they're not opposite reciprocals. So the diagonals, those two blue lines, BD and AC, are not perpendicular. And so if they're not perpendicular, then by definition, ABCD is not a rhombus. All right, I'll let you pause there and get that in your notes. All right, and then for the remainder of the class, you should spend your time working on IXL, graphing quadrilaterals. The 3-letter code is M5F.